It's my pleasure to introduce to you our next keynote speaker, Liz Fong-Jones. Liz is a developer advocate and site reliability engineer with over 15 years of experience. She's currently a developer advocate at honeycomb.io for the SRE and observability communities. She also recently was an SRE working on products such as Google Cloud Load Balancer and Google Flights. And we're proud to have her here on the stage for her first time at DevOpsDays DFW. So, Liz Fong-Jones.
Hello, everyone. I know that I have the difficult task of trying to hold people's attention right after lunch. You know, the lunch coma is setting in. But I do have some nice illustrations drawn by my friend Emily, so hopefully those will help you stay awake a little bit. So today I'm going to tell you about how we can make our systems easier to understand and easier to run and less painful for all of us. And it's not necessarily going to be only focusing on the technology. I want to especially talk about some of the cultural practices and processes that we can follow. So our world of running production systems is increasingly complex. Every day we stand up more and more microservices. Every day we navigate having more and more environments, whether they be on-premise, in the cloud, or a hybrid cloud deployment. And we have to think about how do we navigate and manage all of this complexity while having the same number of people or even fewer people. How do we do more with less? And what does uptime even mean to us as people who operate modern distributed systems? Are our systems 100% up or 100% down? Is it measured in whether you can ping my server? Is it measured in the number of complaints that my help desk gets? What about juggling everything else? When you're not worried immediately about the uptime of your service, how do we deal with the challenge of doing all of the other things that we have to do, like push out releases, develop code, write new automation? How do we manage to find the time to do all of these things? So we need different strategies than the ones that we've employed for the past 5, 10, 15, or 20 years. We need to think about how we sustainably operate our production systems. And above and beyond all else, I want to encourage you to not buy DevOps. With much respect to my vendor colleagues out in the hall, our job is not to sell you software that's going to magically solve all of your problems. Because let's imagine what happens if you do try to buy DevOps. If you buy the alphabet soup and want one of everything, right? Like we said earlier, that you want production ownership. So let's go and buy PagerDuty. Let's put all of our developers on call. That's going to magically solve all of our problems, right? Or what about continuous integration and continuous delivery? Why don't we ship more broken shit faster? That's going to solve all of our problems, right? Or what about infrastructure as code so that when you write one line of code, you can take down your entire Amazon environment at once? That's going to magically solve our problems, right? Or how about Kubernetes? I don't even know what a Kubernetes is, but I want one because I clearly need a Kubernetes. That's what all the vendors in the hall are telling me, right? Not so fast. What happens when you put all of your developers on call without preparing them first with the skills that those of us who have lived on the operations side of the world for years know is that your developers wind up getting woken up all the time. They're grumpy. They're tired. They cannot think and be creative. And they get more and more frustrated. Also, again, with much love and respect to Honeycomb's competitors, and even poking fun at myself, right? Like, when you make walls of meaningless dashboards, when you have a vendor who comes in and says, I will automatically instrument everything for you, right? Now you have not only the 10 dashboards you created reflecting your past 10 incidents, you also have 100 dashboards that you cannot make any sense of because they weren't created by you, they have no meaning on your problem. Where do you even start debugging? You spend your first 20 minutes every time you get paged trying to figure out which dashboard should I be looking at. And your customers get increasingly and increasingly impatient with you. Because the incidents that happen take forever to fix because none of the tooling that you've introduced is helping you solve these problems faster. It's just adding additional complexity and adding more and more things for your engineers to check off before they can actually get to work. And even when you do successfully solve an incident, it winds up being because you talked to that one engineer who knows everything about the system. And heaven forbid, if that engineer goes on vacation or quits the company, how many of you are that engineer? Let's be honest with ourselves for a second. How many of you are that engineer, at least in part, right? Like, it's a terrifying feeling not being able to go on vacation. And it's a terrifying feeling for your colleagues, too, knowing that they cannot solve outages because they can't figure it out because it's too complex. And even if we have the most perfect, beautiful continuous integration system in the world, it turns out that if you are not checking the dependencies between your systems, if you're not checking the intersection, the glue, the connective tissue between each component of your system, you're going to wind up like this sad robot who cannot walk because their knee is broken. Oh, but their leg is fine, and their thigh is fine. Why can't they walk? And all of us get more and more burnt out in this situation of adopting DevOps, in air quotes, without actually changing how we do our business, how we do our jobs. Because you wind up feeling like you're constantly juggling balls of fire, and they're burning your hands, and you can't set them down for a moment to go and fix your projects and go and fix the situation. And even when you do find a scrap of time, maybe an afternoon, maybe a couple of hours, when no one's pinging you on instant messenger or your pager isn't going off, if you don't have a plan for how you're going to get out of here, you're going to wind up just cycling and cycling and not actually getting anywhere and not actually digging yourself out. So in this situation, you and your team are really struggling to hold on. I hope this resonates with some of you, the idea of feeling like you're overwhelmed. So I think that in order to solve this problem, we have to go back to basics. We have to think about why are we here, who are we serving, and from there we can build more sustainable systems. So we have to start with the who, and it's ultimately humans who develop systems. And therefore, we cannot get tools to do the job of humans. A human can figure out how to do something and then send it off to be automated or send it into some automated process. But your tools cannot help you do something that you do not yourself understand how to do. So instead, we have to think about how do we invest in our people, in our cultures, and in our processes in order to help build more sustainable production environments. So this is what I'm telling you about today. It's the art not just of production ownership, but instead of production excellence. Production excellence is what you get when you make your systems more reliable and friendly and make them easier to operate. You can't get there by accident. You have to come up with a plan. You have to come up with a strategy. You have to figure out, how am I getting from here to there? And we have to start with measurement. We have to start with understanding, where are we? No, really, where are we? Not where are we in denial, where are we? And then figure out, how can I make progress? How can I be agile? How can I incrementally deliver changes to my process to make it better for the humans before they all burn out? And we can't just do this alone. Even the set of people in this room, we cannot do this alone. Because production systems require a large number of people to care and feed. And it's not that we're doing a bad job of it, but instead that we need to involve lots of different job roles. For instance, we need to make sure that we're including our customer support team. We need to include our product team. We need to include the people who are counting the beans. We have to include our product devs and our operators and those of us who wear multiple of those hats at once, right? I really liked what I heard from Adrian this morning about kind of dismantling these silos between your teams and saying, you know what? We are the team responsible for this product, right? We're not a separate product and finance team, right? You have to involve everyone, or else you're going to wind up building things that only work for one subset of the people at your company. And this also means that in order to fully include people, and I love this about Quintessence's talk this morning, right? You have to make sure that people feel safe and welcome to ask new questions. Because if you don't, then you're having people who feel like they're less than other members of your team, or that they're not able to freely share feedback, or they're not able to contribute. And that really hurts all of us when we can't benefit from the wisdom of everyone at our company. So how do we get started with doing all of this? I think there are 4 things that we need to pay attention to. I'm going to spend the rest of this talk going over it. First of all, we need to know when our system's too broken. And when they are too broken, we need to be able to debug them and put things back together and restore them to working order. And we need to collaboratively do this. We need to do this in cooperation with other teams, other parties. And finally, when we're done with putting out fires, we need to think about how do we make the system better. You always need some degree of complexity in your system because that's what delivers value. But some of your complexity is unnecessary complexity. That's just making your life harder. So we need to make sure that we have a consistent process for investing in making our systems better. So those are the 4 things. It's being able to know when things are too broken, debug with other people, and then close that feedback loop at the end. So I'm going to postulate that our systems are always failing. Every blade of grass in your lawn is not green, I assure you. Unless, maybe you're operating like a Trump golf course or something, I don't know. But otherwise, there are brown blades of grass in your lawn, and that's fine, right? Your systems are always failing at some microscopic level. But what matters is the overall health of our services. And thinking about how can we quantify that? How can we measure that? With the previous talk on setting kind of a risk budget, right? Thinking about what is an acceptable level of risk? What is an acceptable measure of brokenness? So we need the idea of service level indicators, which I know that Damon touched on a little bit, but I'm hopefully going to go into a little bit more depth here with my time with you. So a service level indicator and a service level objective is a way of getting common language between you as an engineer, other engineers on separate teams, your product managers, and the overall business. It allows you to communicate, this is what the expected level of reliability is for my service. This is how much it's going to cost if we have downtime. And from there, we can make smart engineering decisions about what we want to do and have everyone on board with it. In order to define a service level indicator, we need to think about what the customer experience is. What is a customer's experience as measured by a single event? For instance, I might consider, if I were operating an e-commerce site, an event being the workflow going from a customer checking out and hitting that payment button, right? How long does it take? Did it return with an error? And what are all the other pieces of context? Like, what kind of card were they trying to pay with? What item did they add to the cart? And making sure that you have all of that information that's rich that you need to be able to figure out what commonalities your events have. Once you have an event, you have to be able to classify it as good or bad. Was this a good customer experience or a bad customer experience? And ideally, you as a human would not want to be evaluating that millions of times per second, so can you teach a machine how to do it? And I don't mean fancy neural network machine learning. What I just mean is being able to quantify the notion of user grumpiness, and your product managers can really help with that, or your user experience designers. For instance, I might decide that a threshold that buckets a good event from a bad event is, did it take less than 300 milliseconds? Or did the user decide that, you know what, it's taken longer than a third of a second, I'm giving up and I'm closing the tab, right? So did it take a short enough period of time, and did I serve them an error? If it took a short enough period of time and I didn't serve an error, I'm going to count that as a success. Otherwise, I'm going to count it as a failure. But there's one more wrinkle on this. You probably don't want to include your health checks in this. You probably don't want to include botnet traffic in this, right? You have to think about the idea of which events are eligible, as well as which events are successful and failing. So once you have that total number, then you can just calculate your availability number. It's just the number of good events divided by the number of eligible events. And that helps you set a target that you're aiming for, which is your service level objective. So a service level objective fundamentally relies upon not just having a target percentage, but a window over which you measure it. Because it doesn't matter if I was 100% up 5 minutes ago if I'm now 100% down right now for 2 hours, right? We kind of have to have a memory because our customers have a memory. So for instance, I might aim to have 99.9% of checkout events succeed over the past 30 days. That way I'm not stuck forever if I have an outage, but at the same time, I know to slow down for 30 days in order to make sure that my customers don't become even grumpier than they already are. And then they'll forget in 30 or 60 or 90 days. So a good service level objective just barely keeps your users happy. Why do I say barely keep your users happy? Well, remember, part of why we're here is to increase the agility of our organizations, to increase the speed with which we can develop features and release them to the public. Getting product market fit is something that's a race often, right? You're racing against your bank account running dry. So we have to be able to move quickly as we can while not sacrificing on making our users unhappy. So yes, it is okay if you have to press refresh every now and then because the page didn't load right the first time, as long as it's not too often. Or it's okay, as the previous presenter mentioned, if you have to spend $25 million on mitigating a breach, as long as you're not spending $1 billion on mitigating a breach. But don't spend $100 million to prevent a $25 million breach. That's just silly. So what can we use service level objectives for? Well, we can use it for two things. Number one, all of that pager noise. Every time that you get woken up because a disk filled up to 90.001%. 90.001%. This is terrifying, right? That doesn't matter. The only thing that matters is the happiness of our users. So we can think about setting targets for reliability. If I want 99.9% availability, that means 1 out of every 1,000 events can fail on average. So if I serve 1 million events over 30 days, 1,000 of them I can allow to fail either because they're too slow or they're serving an error. And then I can ask questions like, at the current rate, how long will it be until I exhaust that budget of 1,000 errors I am allowed? And if it's a matter of hours, then yes, please do wake me up. But if there are no end users being served errors, or if it's going to take days for me to exhaust that quota, you know what? I can deal with it during business hours. I don't have to deal with it right now at 2 a.m. The other thing that SLOs are great for is they're great for making business decisions, such as, do I need to invest more time and effort in reliability, or can I take more risks? Can I move a little bit faster because I know that it's okay to burn a little bit of my error budget? For instance, if you use feature flags, you can think about deploying something that might break 1% of your users because you know you have a plan to roll it back quickly and you know you're okay with accepting the risk that you might serve 1% errors for 5 minutes. And that might help you get that feature out the door faster. Or conversely, if you're having too many outages, as Damon mentioned, right, SLOs have to have teeth. You have to have the consequence of if you break your SLO, right, like similar to running out of money, right, if you come in way over budget, maybe you need to cut back on your spending. Maybe you need to go and invest in that project that you're going to do to increase your reliability. But I don't want you to walk away from this thinking, oh, she's from Google, right? Like, you know, only she could do this because she's from Google, right? Like, if you're not measuring it, you have no chance of improving it. Start by measuring something, anything, right? You don't have to have super fancy real user monitoring from Catchpoint, right? You can just come up with an in-house measurement that will suffice for now, and as you get more comfort, then you can go ahead and increase what you're measuring and increase the surface area. The other thing I want to emphasize is that SLOs are not a fixed quantity. SLOs are not something that you set once and forget about forever. It's an ongoing dialogue with your product team and from your product team with your users. Was this reliable enough? Or even, if we had an outage and none of our users noticed, Maybe it means our SLO is too strict. Or maybe if all of my dashboards are green and my users are complaining, maybe the dashboards are the thing that's wrong, not the users. So when you alert only on what matters, that really frees up your brain to sleep more at night. And that means that you can get a lot more work done. It's wonderful. But knowing when things are too broken is not the only thing that we need to fix in our software development and operations lifecycle. We also need to think about when we get alerts on when things are broken, how do we actually fix it? How do we debug it? And I'd argue that runbooks can help, yes. They can help you mitigate more quickly. But your outages, the fundamental underlying contributing causes, those are never exactly the same. Your last outage is not going to be the same as your next outage and the outage after that. So why are we building all of our products and debugging capabilities around debugging our last outage? Shouldn't we be focused on solving newer problems instead? You cannot predict what those failure modes are. If you try to focus on that microscopic failure mode right there, you might ignore the fact that there's a giant failure mode looming right over here, right? So we have to think about how do we build generic capabilities to solve problems. And you can't just wait for your problems to show up in staging either, or say, you know what, that didn't reproduce in staging, therefore it's not a problem for any production users. No, that's denial, right? You have to be able to debug new cases that you've never seen before in production where they happen. And we have to be able to support ourselves as engineers in forming hypotheses about what we think is going on in the system and refining our mental model of what's going on in the system. Because if you do not do that, then you wind up either constraining yourself to a narrow set of hypotheses that you've thought are the only possible failure causes of my system, or you're otherwise inhibiting your engineers from getting to the meat of what's going on in your systems. And that means that we have to have enough data to understand, and we have to be able to query that data in new ways rather than using the same set of dashboards. So all of this is to say that our services have to be observable. And yes, there is the systems control theory that says that we can observe the system if we can understand what's going on based out of its inputs and outputs. But I like to think about it more in terms of what impact does it have upon my life as an engineer? Can I ask questions of my system without deploying a single line of code? Can I have sufficient telemetry and insight into my system to understand what's going on in order to solve a business problem that I have, in order to solve any arbitrary business problem that I might have with my system being slow or down? So in order to do that, we need to have that rich set of events that are contributing to my service level indicator, and we have to be able to examine the full context for them and understand what are the common factors. What's going on with the slow requests? How are they different from the fast requests? Maybe they're missing the cache. Maybe they're all hitting one slow database server. How will I know that? Well, the only way that you can know that is to be able to understand what path the requests took and kind of how they got delayed and what happened to them in the full context, and be able to explain the end user visible behavior of it being slow with what actually happened in the system. And what's even better than being able to do that at 2 a.m. is being able to have your system automatically mitigate it at 2 a.m., not even have you wake up. And then at 8 a.m. the next morning, you can go look at it and debug and figure out what happened afterwards. That's really the gold standard. So service level indicators and observability go really well together, because SLOs tell you when are things too broken, and observability helps you debug when things are too broken. But those two things alone do not create collaboration, which is an essential piece of this puzzle. Heroism is not a sustainable strategy. Being that one engineer who knows everything, who gets woken up every time there's an incident, that's not sustainable. We all deserve the right to go on vacation sometimes. And that means that we have to work together. We have to share that knowledge with each other and share that understanding so that you can virtually look over someone's shoulder, either in real time or afterwards, to understand how did they solve this incident. Maybe you do that in the form of retrospective. Maybe you do that in the form of chat ops. Maybe you do that in the form of just sitting over a computer together. But we have to be able to debug together, otherwise we're not learning from each other. And that also means that we have to empower everyone to debug. What if we level up every single one of your support engineers to be just as good as debugging as your operations engineers? Wouldn't that be great? Right, all of us have a role to play in debugging, and we can all learn from each other's debugging skills. We also have to be able to work together with each other, because collaboration is really, really interpersonal. And I love what Contestant said about like not telling people RTFM, go away, right? We're not bastard operators from hell anymore, right? Like, this is not the 1990s. This is not the 1980s. We can do far better than that. When you tell people things like, thank you for asking that question, or I'm sorry the documentation wasn't clear, let's go fix that, it sends a much better message than telling people, go away, noob, you didn't read the manual. We have to be able to lean on our teams. We have to be able to work together, because no one person can be on call 24/7 forever. And that means that we have to do things such as letting people who are new parents have their parental leave without being bugged. It means that we have to let managers not do on-call during the day, because it sucks when you're having a one-on-one with your manager that's so super emotional and then they get paged, right? That really sucks. So why put your managers on call when they're having meetings? Why are we putting people who observe Shabbat on call on Shabbat? Seriously, like, that's not okay, right? We have teams. Our teams have the capability to be on call. We don't have to make every individual be on call at every single hour. And we learn much better from each other when we write down the right set of documentation. That doesn't mean write down misleading or outdated documentation. It means write down enough so someone who is new to your system can understand what's going on and understand, how do I put out the fire quickly so I can now operate at a lower stress level, so I can debug in peace without feeling like everything is riding on me. If you fix that hero culture, if you share out that knowledge, it makes your team a lot better able to support your services and makes your service a lot more sustainable. We have to reward curiosity and teamwork. For instance, at Honeycomb, we have a Slack channel that's #love. And that Slack channel is full of people praising each other for saying, thank you for helping with that bug, or thank you for resolving that customer concern, right? It helps us feel a lot more connected to each other as teammates. And we have to also not just collaborate with our current coworkers, we have to collaborate with our future coworkers, including ourselves. You are your own future coworker, I assure you. So we have to learn from the past in order to reward our future selves. Because I said earlier that not every outage is identical, and that's true. But outages definitely can sort into patterns. And you can have patterns of failure modes that you can address and save your future self a lot of trouble. So we have to be able to do risk analysis. We have to be able to look forward and plan and deal with the things that we know about. That doesn't help us deal with unknown unknowns, but we can at least deal with our known unknowns. So for instance, in that last slide, you may have noticed that there is a car falling off a bridge because the the roadbed was falling through. And maybe it needs an earthquake retrofit in 20 or 30 years. And I don't know, maybe some of the lights on the top of the bridge are not working correctly. Which one of those do I prioritize working on, right? I have to fix the biggest issues first. So we have to think about reliability in a quantitative way. It's going to be imperfect always. We can think about, how often do we expect this failure mode to happen? How long does it take us to discover it? How long does it take us to fix it once we know about it? And what fraction of users are impacted by it? For instance, if I know that every Friday afternoon my continuous delivery system starts getting slow because everyone's trying to check in their code before the weekend, right? That is an outage that happens every single week that impacts 100% of your users of the CI system for several hours, right? So that allows you to kind of put an order of magnitude of how much risk is involved here. And then we can think about ordering them by that multiplied out magnitude and think about which of these risks are the most significant. Which ones should I be most worried about? And especially what I'd encourage you to think about is the risks that are most significant are the risks that threaten your service level objective. If you know that 1 in 1,000 requests is allowed to fail, and something is going to cause 1 in 2,000 requests to fail, congratulations, you have just burnt half of your error budget on that one failure mode that you know about alone. Maybe you'd better fix that because there are probably other failure modes that are causing you to stack up and exceed your service level objectives error budget. And even worse, that isn't even budgeting for the unknown unknowns that you don't know about. So we have to think about making the business case to fix these risks by pointing out, hey, this is what we agreed to. We agreed that the service needed to be available to 99 out of 100 users, or 999 out of 1,000 requests, right? So if we know that something is causing us to risk missing that, we have a very compelling business case to invest effort in fixing them. But we have to actually prioritize completing the work. Too often, I see people writing blameless retrospectives or postmortems and writing out this really, really long list of 10 action items that they're going to do. Guess how many actually get done? Often, the number is 0. So instead, think about which ones of these am I actually doing, which one is actually worth doing, and actually do it. And then you'll find that you're not repeating outages over and over and over again. We have to do this prioritizing, or else we're going to wind up chrome polishing. We're going to wind up working on making our shiny features as shiny as possible and disregarding the fact that our infrastructure needs work. But I think that there are 2 key things that we don't think about enough, which is that if you do not have observability, that is a systemic risk to your service. Because if you do not have observability, it means that every outage that you have takes at least 20 or 30 minutes longer. Multiply that by every incident that you have, and it adds up really, really quickly. We have to be able to debug our systems, or else we have no business running them. Because if we can't debug them, if we can't put them back into working order, then maybe those systems are not worth us supporting. But also, if you cannot collaborate with your coworkers, if you have coworkers who are afraid to speak up because they were told, oh, that's a problem between keyboard and chair, right? That's really dismissive, and that puts people off reporting the next time that there is an incident impacting a significant number of users. Is that person in the call center going to call you up the next time and say, hey, I think we have a problem? So we have to work together in order to surface incidents and resolve them more quickly. Being successful in our business does not demand being a hero. Please do not think you are the most important person in the room because you have the line of people out your door. Believe me, that means that you are a failure point and you need to be taken out of the way. So what I'd encourage you to do is think about these cultural principles first and then go see your vendors in the hall, right? It's okay to buy the alphabet soup once you know what it's there for, you know why you need it. But make sure that you're seasoning that you're applying production excellence to your culture first along the way. So when you implement production excellence, your teams get closer together because you're actually measuring what matters, you're able to debug effectively, you're able to collaborate with each other, and you're able to resolve these issues instead of letting them fester forever. So I am at Liz the Gray. You can feel free to ask questions or see me for some stickers afterwards if you're interested in those. Thank you so much. See, if you raise your hand, someone will bring a microphone to you, I believe. I know this is a big room. It can be rather intimidating to ask the first question. It's either that or I've stunned you all into silence and I can't tell which it is.
Hi. So writing SLOs, do you recommend doing that in stories with your product owners or involving operations? Because I find when I add the graphs and start seeing things, I like to think about that as, okay, this is what a normal day looks like. Another company might consider that a stormy day. But how do you recommend getting started with those SLOs?
Yeah, I think that a great SLO starts with thinking about how is someone intended to use this, right? What does a success look like? And then kind of defining what are the potential areas in which they might be unsatisfied with this, right? So for instance, if I were thinking about a generic e-commerce site, right, I might start with just the basics, right? If a user can't load the homepage fast enough, then they're just gonna bounce, right? So just thinking about, okay, I need something to bracket the performance of my homepage. But then as you get more sophisticated, you can think about other user journeys, right? You can think about the user journey of someone doing a search for their favorite cat tote bag, right? Or you can think about someone doing a search for some other kind of like printed merchandise, right? And you can say, okay, did the search return relevant results? Did the search return results fast enough? Did it return enough results, right? Was the user able to add the item to their cart and check out, right? Like all of these various workflows. So I think that you have to approach this from the product user story perspective for sure, because otherwise, the one anti-pattern that I've seen people do is say, great, I'm monitoring disk percentage. I'm going to create an SLO around disk percentage, and I cringe, right? Because it's like, no, the disk percentage of your service has nothing to do with whether or not users are happy, right? So measuring user happiness using user journeys. So it's definitely takes that product mindset. Does that answer your question?
Yes. One follow-up, how do you go about thinking about that and rolling it out into QA and testing those metrics, as you probably don't have the same.
Yeah, I think that's a great question of how do you think about your development in QA environments? I think that development in QA environments are great for catching some things, right? Like if you're binary crash loops, of course you shouldn't be rolling it out, right? Like you should be catching that in QA or staging. But I think that past a certain point, the complex issues that you encounter in production, you're not going to be able to reproduce in QA or staging, so it's not necessarily worth investing a lot of effort to try to be able to recreate them in QA and staging, right? So I think that for QA and staging, it's a matter of, does my synthetic load test return fast enough, right? Just as a basic check on, is this roughly in this correct ballpark? But the real test is, how does your service level objective behave once that binary is rolled out to production, right? If I suddenly notice that I'm going from 99.9% of requests succeeding to 99.5% of requests succeeding fast enough, that indicates I have some kind of a performance regression. Sorry about that. So that's kind of what I look for is my SLO roughly going to be met based off of what I see in staging, but then actually verifying in production?
Thank you.
Question about SLOs. Do you have any guideline around how many SLOs per product area as a best practice? And I have a second question. You talked about one of the uses of SLOs being used for alerting. There are many other metrics like the ones that you alluded to that may not be SLOs, like disk issues or CPU issues. Won't those be a leading indicator? And won't those actually serve you better in terms of seeing production issues rather than getting at SLO level, which may be too late?
Yep. Okay, so let's address the first question first, which has now slipped entirely out of my mind. Sorry.
Number of SLOs, best practice, number of SLOs per product.
Number of SLOs per product, right. Typically, any given product feature will typically want a latency SLO and an availability SLO. And some products may also benefit from data integrity SLOs or kind of relevancy or freshness SLOs. But in general, once you get past more than like 4 SLOs per service, it starts getting really unwieldy. So instead, past that point, you sort of have to start bucketing things, right? You might decide that your shopping cart service is close enough to your homepage service in that it demands interactive latencies, right? As opposed to your batch data processing service, which may be able to tolerate hours of latency, right? So I think that you can start categorizing your SLOs and lumping them together once you get sufficiently many of them so that they don't sprawl out of control. So with regard to your second question of leading indicators, I do think that leading indicators can be important, but the problem is that a lot of your leading indicators don't reliably lead to failures, right? So for instance, I do know that for a service that I run, right, if Kafka gets out of shape, predictably an hour later, all of production will be down, right? So therefore, we do have alerts on things that are not SLOs, on things that are Kafka, right? And I think you have to keep that set very, very constrained to things that you know cause failures. The other thing is that if you have a lot of very flappy stuff, it is okay for you to silence those flappy alerts and to let failures happen, right? That's what your error budget is there to absorb. Your error budget is partly there so that you don't have to care about everything so that you can get a good night's sleep. So I think that's kind of how I balance it is, does this always lead to a failure? Can I tolerate the failure happening? And I think often the answer to can I tolerate the failure happening is yes rather than no. For instance, your disk filling up. You know what? If the disk on a VM fills up, the VM will become unhealthy. It'll start returning negative health checks. The VM will be restarted. We'll get a clean VM. That's okay, actually. That's fine. That's not a problem, right? So I think that it's only situations that have the potential to lead to cascading failure. Those are the things that you probably want to set a preliminary check on that's even before your SLO fires. Does it help? Cool.
So this is a question regarding application development. So my question is there a correlation between SLO and the test event development, like code coverage percentage and automatic testing? And if there's a correlation, then what is the recommended percentage that you recommend? Let's say if I want to have a 99.99% availability, do I need 85% code coverage? Is there some guiding metrics that we should follow?
I think it goes back to what Damon said about limiting the amount of toil that you're doing, right? In the same way that you have an error budget, you also need to have a toil budget. How often am I willing to be woken up? How many times do I have to get woken up before I cannot effectively debug things anymore until I'm just, pressing the PagerDuty button and I'm just, acting like a robot, right? So I think that in terms of the correlation, there's no numerical value for that. It's up to how overloaded is your team. Right? And I think that the more potential alerts are fanning into your team, the higher standard you have to set for which alerts actually page you. Whereas if you have only one or two things that you're considering setting up to alert your team, then you know what? That's fine. Let them alert your team. That's okay, right? So I think that that is very much a matter of situational judgment. Let's see one question in the back there. For some reason, this side of the room is a lot more loud than this side of the room. I don't know why.
Hello. Question in terms of you were talking about collaboration and spreading knowledge and all that. I was curious if you have any stories of successes on say you have someone who's a very strong resource, very technically strong, so much so, more so than the rest of your team, and a way to kind of almost incentivize, because sometimes you have these people who are very, I would say, kind of goal-oriented, or almost like a way to incentivize some of that, right? I don't know if you have any stories of success with that.
That's definitely something where that person may be tired of answering the same questions over and over, right? Just get them to write down every time that they help someone with something. Or maybe if someone goes to that person looking for help, if they wind up writing down the answer rather than saying, okay, thanks for helping me, and then going off and not writing it down themselves, right? I think that documentation can definitely be very helpful there. I think the other thing that I find to be really, really compelling is the idea of even if that person isn't actively writing down what they're doing, to make it possible for someone to see what they're doing. And I recognize that this is not a sponsor pitch, so I'm going to be very careful about how I phrase this, but it is possible if you have a sophisticated enough querying tool to have the kind of footsteps that someone took when they were debugging something. If you record the sequence of steps that someone went through to debug something, that's really powerful for someone else to revisit or template their own queries off of to understand how did this person solve this, right? Without having to personally interrogate that person about it. So I think that there are a lot of things that are kind of very chat-opsy that do that, where you can document what happened during a postmortem in a way that doesn't necessarily require someone to actively to too actively curate it, as long as they're just pasting in links into a Slack channel as they go along. So I find that that can be helpful for knowledge transfer as well, is kind of getting some of that magic out of how do you debug a system. If you can actually just reduce it to, this is the blueprint, or this is the recipe that I followed. This is the set of tricks that I know.
Thank you.
Awesome. Thank you very much, and I'll be around for at least a couple of minutes after this talk. Thank you so much.